SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Hello students, my name is Professor Virali Bora and I work with HL Institute of Commerce as a visiting faculty which is located in Ahmedabad city. So the topic that we are going to study today is very interesting for the reason that this studies every one of us uses in our day-to-day life. Not only the people who have mastered in this art, but also the kids, also the elders, and everywhere we use the applications of this topic. So before we start the actual topic, I would like to explain to you where did it come from. As in, the topic is transportation problem and it is a branch of operations research. So operations research, first I would like to talk on operations research. What is operations research? Yeah, so as the name says, it's about operational management. There are a few terms that are also associated with this topic called operations research. The different names are, these names are used in different fields. People also call it operations research or operational research. They also call it management science. They also call it operations management and of course decision science. So decision science, that explains a lot about what does it mean by operations research. So operations research is nothing but an art of making rational decision. The history is very interesting here. The area of operations research came into existence during the World War II. It was when the country needed to have some management in applying to the World War II. They had a shortage of war and they had to decide that which equipments to use the best way such that the country can win the war. So the country asked for some masters to come and study the current situation and then lead to a conclusion which would help them to use the equipments in the best optimized manner. So operations research is nothing but an art of optimization. Optimization of what? It's optimization of time, it's optimization of cost, it's optimization of time and cost, depending on the situation that we are handling. So there are a few mathematicians and few statisticians who have given different definitions of operations research. Arthur Clarke says that operations research is an act of winning wars without actually fighting. Also, H.M. Wagner says that it is a scientific approach to problem solving for executive management. And T.L. Sati says that it is an art of giving bad answers to problems which otherwise have worse answers. So he has tried to put it in a humorous way. According to them, if we try to understand what they actually try to say with the different definitions, that we can understand that operations research is not necessarily a study to make a proper and a correct decision, but it revolves around the study of the current situation with considering the objectives that we want to reach and then reaching to a situation where we can take a proper and a clear decision. There is a very interesting methodology associated with the studies of operational research. So, as I said earlier, the first phase of operational management says it's wise to define the problem. The first phase is to define the problem. And then, after we know what is the problem, we move ahead and develop a model. By model, here we mean that we have different mathematical and statistical models which can be used to solve the problem. So, the problem that we are taking into consideration, first we define the problem and then we discuss the model which is best suited for the current situation. The third phase is to obtain the input data. the data of the current situation, we collect that first and input into the model that we have selected to study the operations management. The next phase is to solve this model. After we have selected a model and inputted the data, the next step consists of solving the model with the help of computers. And the next step is to test the solution. So after inputting the data into the model and running it on computer, we lead to some solution, and that is when we test the solution. As soon as we test the solution on the computers, we have the result. The result which we can use to analyze if it is really working or not to the current situation. And the next step is to implement the solution, is to actually implement the solution to the current situation, to the current problem that we are talking about. So these are the phases of studies of operations management for any case that we are trying to solve. There are different techniques used in the studies of operations management. The models which use the act of allocation are linear programming problem, transportation problem, and assignment problem. Then we have replacement model too. And then we have networking models. For example, the area of PERT and CPM. We also have sequencing model which deals with the queuing theory. And the inventory models, routing models, and a few more like decision theory, game theory, simulation models, and Markov chain models. So today, out of all these models, we are going to study the transportation problem. What is transportation problem? As the name says, transport various quantities of a single homogeneous commodity to different destinations in such a way that total transportation cost is minimum. Let us try to understand what it means. I'll try to explain this with the help of an example. Consider the grocery store, where we get the routine fruits and vegetables. So it is a place where a daily supply and demand issues are solved. There are different suppliers and there are different destinations. There are different commodities which need to be picked up from the supplier and to be dropped to the destination. So transportation problem deals with deriving a route transportation problem such that the cost of transportation is minimum. For example, let us see the mathematical model of transportation problem. Here we have a company which has 3 production facilities, say 1, 2 and 3, with production supply or capacity of 7, 9 and 18 units per week of a product respectively. These units are to be shipped to 4 warehouses A, B, C and D with requirements of 5, 8, 7 and 14 units per week respectively. The transportation costs per unit between factories to warehouses are given in the table. So if you look at the table, you can see different origins 1, 2 and 3 shown in the green color. We have different destinations named A, B, C and D shown in the blue color. So basically the problem revolves around picking up this product from origins 1, 2 and 3 and delivering them to the destinations A, B and C and D. The numbers like 19, 30, 50, 10, 70, 30, 40, 60, 48, 70 and 20 are the different transportation costs that are associated with different origins and destinations. Also, the supply numbers like 7, 9 and 10 means that origin 1 can supply 7 units, origin 2 can supply 9 units and origin 3 can supply 18 units. while on the other side, the destinations, the demands, right, yes, the demands, the 5, 8, 7 and 14 are the numbers which says that destinations A, B, C and D are in the requirement of 5, 8, 7 and 14 units respectively. So when we are given a problem like this in words, we have to formulate the problem and put the numbers, put the data into a matrix form as shown here in the table. Using the linear programming technique, we will try to develop and formulate the model as shown. Here, let Xij, number of units of the product to be transported from factory 1, factory I, which can be anything out of 1, 2 and 3, and warehouse J, where we have 4 warehouse 1, 2, 3 and 4. So the above transportation problem is stated as a linear programming model as below. Our problem is to minimize the total transportation cost, denoted by Z, which is 19 into X11. Here 19 is the total transportation cost and X11 is the unit that we will try to find out. So we can say that in the problem shown above, the total transportation cost Z is equal to product of all the transportation costs and the respective units. We also have certain constraints here. Here we can say that X11 plus X12 plus X13 plus X14 is equal to 7, where X11, X12, X13 and X14 are the different transportation costs, and 7, 9 and 18 are the different capacities available with different suppliers. Similarly, in the second equations, X11, X21 plus X31, which says 5, 8, 7 and 14 are the different demands required at different destinations. So, in the above LP model, there are M cross N, which means 3 into 4 equal to 12 decision variables, and M plus N, which is 7 constraints, where M denotes the number of rows and N is the number of columns. Now let us try to understand the general mathematical model of transportation problem. Let there be M sources of supply S1, S2 up to Sm, having AI units of supply respectively, where I is from 1 to M, which has to be transported among destinations D1 up to Dn with Bj units of demand respectively, where j is equal to 1 to n. Here, Cij is the cost of shipping 1 unit of the commodity from source I to destination j for each route. And Xij, which we have to find out, represents the number of units shipped per unit from source I to destination j. The problem is to determine here the transportation schedule so as to minimize the total transportation cost while satisfying the supply and the demand conditions. Mathematically, this problem can be stated as follows. We have to minimize the total cost such that Z is equal to summation Cij into Xij, where Cij are the costs and Xij are the number of units. And the constraints are Xij, summation Xij is equal to Ai and summation Xij is equal to Bj, where I are the supply constraints and j are the demand constraints. And of course, Xij should be greater than 0 for all I and j. This is how we formulate a general transportation problem into a linear programming problem. The matrix representation of a transportation problem is shown here. We will try to understand what everything here means. So the matrix here has different destinations, different origins, supplies, demands, cost of transportation, and number of units transported. Let us try to understand which are the destinations here. D1 up to Dn are the different destinations here. And similarly, S1 to Sm are the different origins here. Supply in green here is from A1 to Am. And likewise, demand is from B1 to Bn. The cost of transportation, which would be given in the matrix, are C11, C12, C1n, and so on up to Cmn. And with the help of all this information, we will try to find out the number of units transported such that the total transportation cost is minimum. So we will try to find out the units like x11, x12, x1n, and so on. This is the general transportation problem in matrix representation. Also, in any transportation problem, there are two cases. If the demand is greater than the supply, then we have to add a dummy column in matrix with zero cost. And in some cases, if the supply is greater than the demand, we have to add a dummy row in matrix with zero cost. We will try to understand with the help of an example. Looking at this figure here, the first